So we will continue with the tutorial here. So number 6, example. Okay, we will do only one, and let me write down the question. Consider the map defined as H from Rm to Rn. Okay, represented by the matrix H equals 0, 1, 3, 2, 3, 4, and minus 2, minus 1, 2. 0, 1, 3, 2, 3, 4, and minus 2, minus 1, 2. Okay, so, and it is represented by H with respect to the standard basis. Standard basis. Okay, so here are the question. Number 1, we are asked to find, okay, state, find M and N. Find M and N. Okay, M is the power of R in the domain basis, and N is the power of R in the codomain basis. Okay, in the codomain space. Sorry, M the power of R in the codomain space, in the domain space, and R is the power of this R in the codomain space, not basis space. Number 2, we are asked to find the range space and the rank. Okay, so I should just say find. Okay, because other questions are not fine, but find the range space H and the rank. And the rank H. Question 3. Find the null space and the nullity. Okay, so we are asked to find the null space and the nullity of H. Okay, and we are asked to state whether the map is onto and whether it is one-to-one. State whether the map is A, onto, and B, 1-to-1. Okay, so now let's start the solution here. I can start the solution here so that I can have enough space. Okay, solution A, number 1. Okay, so M, if we see here, M is the number, is the dimension of the domain space. M is the dimension of the domain space. And we have seen that the number of columns is equal to the dimension of the domain space. Okay, so I have the dimension of the domain space equals the number, okay, of columns in the lecture. The number of columns. Okay. Okay, so let's continue, which is in this case, okay, so the number of columns of our matrix, we have 1, 2, 3. So m is equal to 3. And here n is the dimension of the codomain. Codomain of the codomain of the codomain space equals the number, okay, sorry, the number of rows. And here we have 1, 2, 3 rows. So n equals to 3. And also m equals to 3. So question 2 is find the range space. To be able to find the range space and the nullity, okay, here, okay, I'm going to write number 2 here. To find the range space and the nullity, we need to perform Gauss-Jordan method, okay, on okay, let me find the range space. Okay, let me fully write it. Okay, finding, okay, the range space and the rank. Okay, to do so, we need to solve, if you remember, here we have seen that a note here, the column space of the matrix, so which is the range, okay, is the range, okay, so the column space of the matrix is the range of the map. Therefore, to be able to find the range of the map, we need to solve the following equation. Okay, we need to solve the following equation. Okay, we have the matrix 0, 1, 3, 2, 3, 4, and -2, -1, 2, multiplied by x, y, z equals a, b, c. Therefore, to be able to solve this equation, we need to perform, okay, Gauss-Jordan on the augmented matrix. So we have 0, 2, -2, 1, 3, -1, and 3, 4, 2. Sorry, here I should have is an augmented matrix. Here we have A, B, C. So what I'm going to do here is, first of all, we are going to swap row 1 with row 2. So row 1 swap with row 2 will give us 2, 3, 4, Okay, 0, 1, 3, and minus 2, minus 1, 2, and here we have B, A, C. Okay, and okay, I think I have to continue here. Row 1 plus row 3. We have, if we, I'm sure you know how to perform Gauss-Jordan method. If not, then have a look at our first chapter. Okay, so I have 2, 3, 4, B, okay, and 0, 1, 3, A. So now I need to cancel the x on the third row, so I'm going to do row 1 plus row 3. That's why I wrote row 1 plus row 3, so that I can have 0 here, and I have 2 here, and 6, and B plus C. Okay, what I'm going to do next is to use the y term here 1 to cancel the 2 in the third row. Okay, so basically I'm going to do minus 2 row 2 plus row 3. Okay, so we have 2, 3, 4, B, we have 0, 1, 3, and A there, and here 0, 0, so we have minus 2 times 3 is minus 6, so it's 0 here, and you have minus 2, minus 2A plus B plus C. Okay, but we are not done yet. Now we are going to divide row 1 by a half. So you have a half, row 1 will lead us with 1, okay, 3, sorry, over 2, and 2 here, and we have B over 2, 0, 1, 3, A, so 0, 0, 0, minus 2A plus B plus C. And the last step is to use the 1 in row 2 to cancel the 3 over 2 here. So we have minus 3 over 2 row 2 plus row 1. Okay, and I hope I will have enough space. We will keep a third row untouched. So we have minus 2A plus B plus C here, and row 2 as well untouched. Okay, so we have A here, and row 1 here, 1, 0, so minus 3 over 2. So here we have minus 3 over 2 multiplied by 3, so we have minus 9 over 2 plus 2, so it's 2, 4, minus 9, so it's minus 5, minus 5 over 2 here. And when it comes to the right hand side, we have minus 3 over 2A plus B over 2. Okay, I hope you can see. Okay, close it there. So this is our Gauss-Jordan. Maybe I need to rewrite it here before we can continue. Okay, so finally our matrix is 1, 0, 0, 1, 1. Okay, I think I have skipped this page, so I'm going to write it as here is our matrix. 1, 0, 0, 0, 1, 0, and for the third row we have a minus 5 over 2, 3, 0, so minus 5 over 2, 3, 0. Okay, and here we have a minus 3 over 2A, minus 3 over 2A, plus b over 2, and a for the second row, and minus 2a plus b plus c, I think. Let us check. Okay, so the range space, okay, is AB such that the following condition is met, is because there is a restriction on one of the rows. Okay, so the range space, so basically you Gauss-Jordan a method and you see if there is a restriction on a row. If there is no restriction, then the range space is going to be the same as the codomain space. And what does it tell you? It tells you that the map is onto, okay? But here we have a restriction. So here is our range space. The range space is all the A, B, C such that the following condition is met. Minus 2a plus b plus c equals 0. Okay, so we will consider, how do we do that? We have done it several times. We will consider this equation as a one equation linear system. Okay, we will split the bar. Okay, it's one equation, a linear system, and we parameterize it. Okay, minus 2a plus b plus c equals 0. So that means we are going to write the leading variable in terms of the free variables. So minus 2a equals minus b minus c. That means a is equal to b over 2 plus c over 2. That's a. Therefore, our range space, okay, the range space can be written as instead of a we have b over 2 plus c over 2 b and c, okay, which is the same as a half 1 0 multiplied by b plus a half 0 1 multiplied by c such that b and c are free. Okay, therefore what is the dimension of our range space? The dimension is therefore the dimension of the range space of the range space equals 2, which is what? Which is the rank of the matrix. Okay, so rank, sorry, the rank, oh yeah, of the map of the matrix. Rank of H is equal to 2. And here is our range space. If there was no restriction, we will have just written R3, but there is a restriction, so we need to find the dimension of the range space. Is that okay? Okay, so let's continue. We should here probably continue with, we can say clearly if the map is onto, is not onto, because the rank is not the same as the dimension of the codomain. Okay, so the rank of the matrix is not the same as the number of the rows. But let's go one by one. So that was question 2 answered. So we have answered question 1, question 2. Now we are asked to find the null space. Okay, so the null space 3. The null space H is we have already seen. To be able to find the null space, we need to okay, let me write it for those who don't remember. The null space is all V belonging to the vector, the domain, okay, space, such that H of V, okay, equals to 0. in the codomain space. Okay, so if H was defined from V to W, so basically here in our case, these are going to be V elements of R3 such that H of V, okay, equals to 0 of R3 in the codomain, the trivial space. Yeah, the trivial element in the codomain space. Okay, so to be able to do this, we need to solve which equation? To be able to find the null space, we need to solve. So we need to solve the following equation. We need to solve the homogeneous version of this equation. Okay, so we want to find x, y, z such that the map multiplied by x, y, z equals to 0. So we want to see all those x, y, z that map to the trivial element in the codomain space. So, and what is great is we have already solved it here, so we can just change the a's with a 0. But let me write it down. We need to solve the following equation. We have 0, 1, 3. Okay, so, and 2, 3, 4, minus 2, minus 1, and 2, multiplied by the x, y, z, which is equal to 0, 0, 0. Okay, so how do we solve that? We perform Gauss method, and we have already done it, and we have the final answer. That means we are going to rewrite this, and instead of a, b, and c, we are just going to use zeros. Okay, so here we have 0, 1, sorry, 1, 0, 0. So we have 1, 0, 0, and to make sure I have enough space. 1, 0, 0 multiplied by 0, 1, 0 minus 5 over 2, 3, 0. Okay, a is equal to 0, b 0, so you have 0 there, 0 there, and 0 there. Okay, so here we have so that's the final step of that's the Gauss-Jordan performed. Okay, that means now we do back substitution. Here we have a y here. That means y equals minus z. Okay, minus 3z. Okay, so we are going to write the leading variables in terms of the free variables. So is equal to minus 3z, and here x equals 5 over 2z. Okay, so the null space here is going to be, okay, all the x, y, z, okay, such that x equals to 5 over 2 and y equals to minus 3, and here z such that z is free. Okay, so that is our null space, and here is the null space. Okay, we know how to solve a linear system of equations. Okay, so here that means the dimension of the null space is 1. We have only one vector here. Okay, and that is the nullity. Nullity is the dimension of the null space. Okay, so nullity of H which is the dimension of the null space equals to 1. And if you remember, we have seen a theorem saying that the dimension, the rank of the matrix plus nullity equals to the dimension of the domain space. Okay, so the domain, so 2, the rank is 2, the nullity is 1, so 2 plus 1 is 3. And if you remember, the dimension of the domain space is 3, so 2 plus 1 is equal to 3. Okay, and we are not done yet. The final part 4, is we are asked to find if the map is onto. State whether the map is onto. No, the map is onto. Here we have it here in the lecture. We have seen that the map H is onto if and only if the rank of H equals to the number of its rows. Okay, so let's, so it is here. Okay, so the H is onto if and only if the rank of H equals to the number of its rows, or the rows of the matrix representing H. Now let's have a look. The matrix representing H is this, and it has how many rows? 1, 2, 3. 3 rows. But when it comes to the rank is 2. 3 is not equal to 2, so H is not onto. Okay, and because the number of the rank is not equal to the number of rows. Now B is H 1 to 1. Let's have a look what we have said in the corollary here. H is 1 to 1 if and only if the rank of H equals the number of its columns. So let's have a look at how many columns do we have for the matrix representing H is 1, 2, 3, 3 columns, but the rank is 2. So H is not 1 to 1. So H is neither 1 to 1 nor onto. 1, 2, 1. Of course, we can see from the null space. If the null space was the trivial space, we can also assume that you know, we will have deducted that the map is 1 to 1. Okay, but the null space is not the trivial space. Okay, so I think we are going to stop here. So basically, in this tutorial, we have seen how to find facts about the underlying map if we are given the matrix representation. We can find the dimension of the domain space, we can find the dimension of codomain space, we can find the map rank, we can find the range space, we can find the null space, we can find the nullity, we can also find whether the map is 1 to 1 and or onto. Is that okay? So we are going to stop here and I will see you in the next video. We'll continue with the lecture. Thank you.